is visible to all of you. Now let's begin now. Welcome to day 2 of Python Basics with me, Sharmishra. Today we will start on to the other data types that we have left yesterday: list, dictionary, tuples, and sets and booleans. Okay, so let's start first and foremost with list. When I say that word list, what does it come to your mind? A sequence? Some sort of numbered series for us to see, right? A series of elements. It could be like, say, it could be a checklist. It could be a list of apples. It could be a list of vegetables. It could be a list of prospective colleges, prospective job opportunities, something or the other. Basically, list is something. It's a collection or a sequence in Python. All right. So first and foremost, how it's distinct with strings, a data type that we have learned out about yesterday, right? So while string is immutable, lists are mutable, meaning that I can take a particular section from a list and change the value of that particular element on that corresponding index. Okay, let's first start with how I can create a list. Know that this list word is a keyword in Python and you should not use it as a variable name anywhere. Okay, so I'll create a list. Okay, well, what if I want to create an empty list, right? So I can create an empty list like this, or I can create an empty list like this. Okay, you can see here it's an empty list, and LST1 is also an empty list. Basically, in list, all the elements are stored inside square boxes, square brackets. Okay, that's the distinction of a list. In strings, the elements are stored inside the quotes, be it double quotes or single quotes. In list, the elements are stored inside square braces. Okay, good. Then say I want to create a list of numbers. The numbers being what? 10, 20, 34, 12, 51, 45, 56, and so on and so on. So I can create a list like this and I can print it out. See? Now I gave the values to my list. In C, C++, I would need to generally define the length of my list. Okay, whenever I want to initiate, like the data type which would be the most similar to list in C and C++ would be array or vectors, right? In arrays in C, you need to specify the size of the array before initializing it with any value. Okay. In case any of you don't know what initialization means, initialization basically means providing in the value as well as the data type for a particular object in C. And even in Python, it just corresponds to giving in value to your particular variable. Okay. All right. So here I created a list of int data types. What if I want to create a list of float? Can I do that? 1.4, 4.5, 6.7. It shows no error, meaning I can make a list of float data type also. Okay. All right. Now, what if I want a list which has string elements? If you remember, in the last lecture, we spoke about a built-in function of string called as split function. Okay, let me make a string real quick. St. This is a new string. Okay, Now, what if I want to create a list out of this string? What do I need to do? I need to split it, right? Use the split function. What would the split function do? Separate all these words on the basis of the element which would be provided inside. By default, the element is considered as the single white space. So, what would be my output? My output would be a list of elements. All the elements will be string. Okay. Now, say I want to what? I want to get this alphabet H. Okay. How will I get this alphabet H? First and foremost, we need to assign this thing to some variable, because this does not go and in place separate out the sentence that I had created. Okay, that means it is not saved in any memory space. It is being just shown as a random, as a temporary output, and then it would be removed out of the memory. It's not stored anywhere. So I'll save it in some list. List 2 is equals to this. All right. Now I want to get this H. Okay. Last time we talked about indexing in string. So we saw that if we want to access the element, we need to put in the element index. So in strings and in list, basically overall in Python, our indexing starts from 0. So here the 0th element is this. Okay, we get the letter H. Okay, if I do this, oh, okay, sorry, it's list. I should do list 2. Okay, I got this. Now, how do I get H from here? I know that this whole element corresponds to this string. Now, in this string, what is the position of H? 0, 1. These commas won't be counted as part of the string. They're just there to signify that this particular element is a string. Okay. See, whenever a list is printed, it is printed inside of the square braces. Okay. And similarly, a string is printed inside its quotes. So if I want to get this H out of this, what do I need to do? I need to put in the index value of this, 0 and 1. So, see, easy, right? All right. So, a question arises, can I make a multi-data type list in Python? This is entirely, absolutely not possible in any other advanced level language. As far as I know, in C or C++, I can guarantee that I cannot create an array of multi-data type elements. I would need to create a struct there in C. Okay, so say here, lst22 is equals to, say for the first element I gave 1, second element I gave 2.3, third element I gave, this is a string, this is a string, and the fourth element, what else? We'll be learning about tuples, so why not make a tuple here? 1, 2, 3, 4. And can I make a list inside of a list? Why not? 1, 2, 4, 3, 4, 56, 78. So, do you guys think there will be any error in this? Definitely no. Okay. Now, if you need to access, say 56 from list 22, lst22 variable, how would you access it? As we learned about H earlier, what will we do? LST -1, as this list is the last element of my LST22 variable. Okay, then I want 56. And this 56 element is 0, 1, 2, second index value, or -1, -2. So I'll put in -2. Oh, wait. I mentioned the wrong list. See, I can access that particular element also. Okay, understood? All right. Now, can I do slicing in this as I did in string? Of course, we can do slicing in this. Say I just want this tuple and this list out of LST22. So what would I do? I know the starting element that I want 0, 1, 2, 3, 3 till n. I got a list sliced off of the last two elements. Now, what if I want to add a new element in this? Okay. What would I do? I'll do this. Now, I have added this list. Just tell me one thing. Will this whole list be added as a individual single element, or like all these elements would be added? Let's see. All these elements would be added by. See, if I'm adding a list to another something else, I need to add it with another list, right? I cannot add a list and a string. I cannot add a tuple and a list, right? I need to add a list object with a list object. So whatever elements I had in this list would be added to this list element. But if I want this to be added as a singular list, I'll enclose it like this. And now all these elements are added as a part of the original list. Okay. Now what else? Can we remove or change the value of a particular element? We can say all of this is very numerical data. And the last element is also kind of similar to my this tuple elements. So I want to do is LST22 and -1 to access the last element, and assign is as LST22 -1 star 20. So that my elements change. Now let's see what LST22 will become. Okay. See, what happened here is I forgot to assign this value to another, to my original list. So whatever this output is, it's not being assigned to any element. All right. And this whole value, how did this come out about? You can like make your suggestions and we'll discuss this in the discussions and queries part. Okay, because I want this to be face to face. This would be more fun then. Okay, do remember this part. Okay, I'll just do this. It'll look a bit neat, I think. Quite a lot of elements now. And okay, just make a guess why this happened. Okay, all right. Now moving on, what else can we do? I spoke about its mutability part, right? As you can see, like I can change the individual elements in this. Nothing can not be like that. Okay, if it's been initialized in the starting, it cannot be changed. I can change it at any part of the time. I find that, okay, I do not like this element 2.3. I'll change this element to something else. Okay, a bit small. I'll change the last element as 0 in this. See. is equals to 0, and then I'll print my list 22. This whole long list gets removed and I get this. Okay. Now, what else can we do? As we had many built-in functions for a string, right? We had split function, we had upper function, we had lower function, right? Similar to that, we have many functions for list also. You can check out these built-in functions similarly by doing dot and tab. Okay. Then there are these functions. There's append, clear, count, copy, extend, insert, remove, and all. We'll talk about a few here. Okay. Let's first create a new list and then let's start. Okay, let's create a numerical list now. A simple numerical list of first 9 natural numbers. Okay, this is my list. Very simple, right? All right. Now you know what? I want it to have the element 10 also. It does not look good just till 9, right? I want it to have my last element as 10. What can I do? I can do this, right? This concatenation part, as I told you about earlier. But what would I need to do in this for my list 1 to retain the value? I would need to reassign it, right? Now you can see the value of list 1. It has 10. I played it twice, hence it's becoming 10, 10. 1 second. See, fine. It is getting the value of 10. But what if I don't want to write this much? Do I have a built-in function to do this? I do. Okay. Now let me do this so that it does not retain the new list. Now dot append. Now first and foremost, I'll show you what's the list value. It's still the same. Then I'll append something. What should I append? Instead of numerical 10, I'll append alphabetical 10. Now what does my list 1 becomes? Okay. See, that element gets added at the end of the list. Okay. Now then, what if I want to remove a particular element? Like I know the index of that particular element and I want to remove it. Then what? Okay. Now I'm not that satisfied with that alphabetical 10. I want to remove it out. Now what can I use? I can use a built-in function called as pop. Pop needs the index of the element you want to remove. Okay. And do you think list1.pop -1 will return some value? Let's assign this to some element. Okay. And let's check what my list 1 looks like. See, it changes, it does it action in place. What it means is it will change the original list value, elements that I had provided it. Okay. Now, do you guys think it would have returned something to A, or will there be just garbage values? No. A gets the popped out element. Okay. Like whatever element that we would be popping out could be given to this. Now see, although Python list is very, very flexible, there is something you cannot do even here. You cannot do like this. It's out of bounds. Why? Because I do not have any element assigned to that 100th location for my list 1 or list any. Okay. So if there exists nothing, Python cannot retain that, right? It needs to have something for it to retain or to get back to you, right? It cannot. Okay. Then talking about other built-in functions that list may have, we have the sort and reverse method. Okay. You would have heard about bubble sort, selection sort, merge sort, insertion sort. There are many sort algorithms. They are very important. But say you don't want to write that amount of code, and the compiler in which you're working right now allows you to use such kind of built-in functions, then why not use it? Why not? So we have this function called as the sort method, dot sort. I have, okay, this is already a sorted out list. I'll just take a list which is not sorted. Okay, fine. I'll just create a new list. LST12 is equals to something, 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 something. These are all the elements. I just pressed my keys and whatever occurred, occurred. Okay. Now I want it to be sorted out. I can use the sort function for that. It does not take in any parameter in this, as does the pop or append function. Like append needs the element that you want to add in the end, and pop needs the index of the element you want to remove from the list. But dot sort does not need anything as such. Okay. Now let's see what's become of my list 1, 2. 234. Here is the element 234. In the start, when I assigned the values, my 234th element was at the last third position. Now it's at the first position according to numerical order. Why is it so? It's very simple. It's simply because that is the chronological order. This is the simple ascending order. Okay. There are methods in which you can do in place, out place, and also ascending, descending. You can do true, false. That okay, fine. I wanted an ascending order. I can want it in descending order. Okay. Now, since we have a list in which there were all numerical elements, what if I have a list in which there are string elements only? So to do. Some okay, in double quotes, then another element, okay, another element, do you guys think it will work with this? Of course it would work with this also, because alphabets also have a chronological order, right? The first element starts with H, hence it has become the first element in this list, and so on and so on. Similar to this, we have that reverse method. Now say you want to reverse this whole string. Okay. Like in whatever order this is, right now, my LST13 is this. It's in the original order because I again ran this cell. So whatever this procedure that had happened gets washed over in a sense. Now that I have this list, I want to reverse it. Like whatever it is, I don't care. I just want these elements reversed. Then I use my reverse method. Remember yesterday we did in slicing and indexing the -1 thing? You can do that even here. And you have a special built-in function also for that. This element was the first element, now it's last. The last element is the first element here. See, pretty simple, right? All right. Now, this is something of a complex topic in list. It's called as list comprehension. Okay. You'll learn more about it in details tomorrow, because then we'll be introducing you with Python statements also. So you'll understand more in depth about list statements and such kind of comprehension methods. I'll explain it to you in short. Okay. Now say you want to create a list. Okay. I name my list ran R res. Okay. Now this is my list name. I want to have a particular property associated with this list. That I only want multiples of 3 to be in this list. Okay. So what would I do? I'll assign a variable x for the result for I in range 1 to till 21, let's say. Hmm, should I write? What should I write? X star I star 3. Now let's see what the output. Let's reduce this number. It would become a long string again otherwise. Now what would my rest be? Hmm. Oh, sorry. Yeah. Range does not use this format. It uses a invalid syntax. I will start for I in range. Yeah. This is my mistake. Okay. Let's say for I in I start with. Hmm. Let's let's leave this. Okay. Say I want to print. I get a sentence or I get a word. Okay. Now for that word, I try out some sort of expression for it, right? Like, how do I explain this? Okay, see, as I was talking about list comprehensions, what exactly that means? See, if you would have learned about any Python or any program, any other programming language, or not even say a programming language, if it is something that is a repeated action, we tend to do it in a loop, right? Like, say, the repeated action could be anything like washing your clothes. You do it on a cyclic basis per week, once or twice. That's up to you. And what about, okay, the most cyclic process that we all go through, go to college and come back exhausted in the evening, right? Some of you would not be exhausted. Great. Okay. Point is, sometimes there is a repeated action that needs to be implemented. So, what do we do to implement such kind of action in a programming language? We use loops. You learn about loops tomorrow through Yashaswini. Uh, I'll just use a bit of looping here. Say I have empty list res and I create a string 1 is equals to this is a string. Okay. Now I run a for loop for I in no, let's do something more fun. Okay. LSPSTR, this is my list which consists of my string element. How will I attain that? I'll do string 1 dot split, right? Okay. Now I got my splitted list, right? Let's see what does my splitted string looks like. Okay. This is my splitted string. Now, what I wanted to do is my for loop that if there is a T in the word, then add it to the rest list. Okay. Now, to do that, what do I need to check? There are two types of T first and foremost in all of these words. One is a uppercase T and one is a lowercase t. All right. For I in lst if now I can give a condition here. Since I'm going to be giving two conditions, I'll use parentheses. It's just easier for us to understand. Okay, so what would be my, oh sorry, I ran it by mistake. Let me. So what would be my conditions to get a word in which there is a T? If if T or P in I, press dot append I. See, what would be I here? I will iterate over this list. Okay, this list str that is containing all the elements that we got after splitting my string. Okay, so each individual element would be represented by the variable I right now. Okay, if you are not confirmed, I can print that out for you. Print f current value of I. Okay, now let's see what happens. If LSTR is not defined, oh sorry, LSTSTR, LSTSTR, yeah, okay. Current value of I is this, current value of I is, and so on and so forth. Okay, basically I would be whatever element would be present in this list currently. Okay, now what do you think RES will contain? RES will have string uh, or D. Okay, why did it not take this? Let's try like this. If D in I or T in I. This will work. It got reappended. Okay, so basically I got those two elements. Now it is basically having some condition and it is iterating over a list, right? And what is its procedure? It's basically doing one single task. It's adding that particular element which has T or capital T into my resultant list, right? So what if I want to do it in a single line? Then what? Then I can write this as RES is equals to I for I in the LSP STR list if if T in I, that's to double, or capital T in I. Now let's see what would be a value. This whole three line of code gets reduced to a single line of code. Basically, list comprehension gives you uh, a very concise amount of code to write a whole singular action which is being performed on the basis of a condition. Okay, you can see that this is the iteration part of it here, and this is the condition part of it. List comprehension basically works on this principle that there would be a condition and there would be an iteration. To flat out my for loop, we use this whole method of list comprehension. Okay, I hope that is clear with you all. Then let's move on to our next topic, dictionaries. Okay, now generally we all know what a dictionary is, right? It's something that tells us the meaning of words. Okay, now, dictionary in Python, what is that? It is similar to a sequence, but here there would be mapping. It would be an unordered sequence. In list, or you can say in string, it is an ordered sequence. We know the index value of each and every element. I know the index value for this in this string, in this list. Okay, and so on and so forth, right? But in dictionaries, we have keys which are mapped to values. Okay, generally, dictionaries have the keyword dict in Python and are denoted by curly braces. Okay, if you define it like this, it will create a empty dictionary. You can see the type of this variable. It will give you as dictionary. Okay, now how is a dictionary created? Simply think of it. Okay. As I said, we have keys in it, and those keys have values in it. Okay. Fine. I'll create a dictionary is equals to K1 with the value 45. Okay. Then K2 with the value 65.3. Then K3, oh sorry, then K3 with the value of, sorry, yeah, K3 with the value of some string. This is dictionary. Then can I add a dictionary inside of a dictionary? I can add a dictionary inside of a dictionary. See? Okay, I'll take the key as K4 and the value I'll assign it would be a dictionary. See? KK1, KK1, 12, KK2, 45, and I can even assign a list to a dictionary. Okay. Now let's see what my dict2 is. See, all of these keys are mapped with this particular value. Okay, now we can change the values. Okay, but we cannot access the values without knowing the name of the key it is mapped to. Okay, it's not like basic indexing and all. We have to know the identity or the name of the key to access that particular value. I want to call this dictionary inside of my dictionary too. So I'll call dict2 A4. I got the dictionary in that map to that particular key. Okay. Now, what if I want to access KK2? So, let's try doing this. We got the value. It's similar to nested list, how we access the values of those things. And similarly with list, we can do that. and whatever the element is there inside of that particular map to that particular key, we can perform all the functions related to that data type on that element. Okay, for example, I can do this. We all studied about the upper method, right? Now I know that all the elements in my the elements of my K3 key are a string. So I can do upper on it. Okay. So we can perform the actions of those particular data types on it. All right. Now, can I change the values? Is it mutable or not? Think about it. It is mutable. Okay. Now say I want to change the value of K1 key. So how would I do that? I'll first of all call, oh, it got marked on. I'll first of all call my K1 key. Now I want to change its value. Okay. How I want to change its value? I want to multiply it by 17. Okay. You might have remembered it from yesterday's lecture, variable assignment. Okay, I want to multiply it by 70, and now I want to see what my new dictionary looks like. See, it simply changes that value mapped to that particular key. So this shows that dictionary is clearly mutable. Okay. Now, there are some methods pertaining to dictionary also, as we had with list and strings. What if I want to get what are the names of all the keys? Okay, I'll use this method called as keys method. Now, this returns a list of all the key names of my dictionary. See, K1, K2, K3, K4, K5. These were the only key names that I had given, right? I get the values of the key names. Now, what if I want to get only the values out of it? Okay, then I'll use the method called as the values method. It will return to me the values of the dictionary. It won't return to me what key it is mapped with. It will just return to me what all values it has. Okay, what can I access the key values of this dictionary that is present inside of my dictionary? Of course, I can. See, what was the key associated with this dictionary? It was K4. So I'll type K4 and the values. I get the values inside of it. Similarly, I can do it for keys also. Okay, understood? All right. Now there is one more important method which you guys might find interesting, and you guys would actually use somewhere in coding and all if you look it up. That is the items method. Now, what does items method do? It creates a tuple of the key and the value. Okay, it just has two elements in these tuples, and all these tuples will have the elements of the key and then our element value. Okay, basic. That's the basics of dictionary. We'll go through the assignment, and you guys, if you guys find something interesting, you can talk about it during the discussion. We can discuss it further. Then moving on, we have tuples. Okay, tuples do not have these many amount of methods or functions for it. Like even with dictionary, you will find a sufficient amount of built-in methods. Oh, sorry. See, there are quite a sufficient amount of methods. But with tuples, tuples are this tuple is the keywords denoted for tuples in Python. And say I have a tuple and it is denoted by parenthesis. Parenthesis signifies that this particular element that I have created is a tuple C, the type of P. It's a tuple. Okay. Tuples are also immutable. If we talk about all the data types that we have talked about till now, there is dictionary, there is tuples, there is list, and there is strings. Out of these four, two of them are immutable and two of them are non-mutable. Immutable and two of them are mutable. The mutable ones are list and dictionary, and the immutable ones are tuples and strings. Okay, so tuples is a ordered sequence. Okay, unlike dictionary, which relies on mapping with keys, tuples is sorry, tuples is a ordered sequence. Okay, so how do we create a tuple? I told you how to create an empty tuple. Now, if I want to add values to it, how will I add it? Do I have an append function? Do I have any function pertaining to tuples? I just have two functions with tuples. You saw the number of functions that are with list, strings, and dictionary. Even with int and float, you have a good amount of functions. See, I'll show you. N is equals to 23. And let's see what are the functions pertaining to n. Sufficient, right? Now, if I make it float, how many functions? Still, good amount of function. But with tuple, there are a very few amount of functions with it. Okay. Now I'll create my tuple. So, is a tuple supposed to be entirely consisting of integer data type elements or float type data elements or a singular particular type of data element? No. In this thing, in with regards to this thing particularly, it's similar to list. You can add or dictionary. You can add whatever you want in this. You can add a dictionary inside of a particular element. You can add a list inside of a particular element. You can add a tuple inside of a particular element. See, I'll create one. So I'll take first element to be this, then second string, then let's say another tuple, 1 comma 2 comma which has another tuple, 45 comma 67. Okay, then I will create a dictionary here, comma string, comma 45.7. Then can I add a dictionary inside of this tuple? We can add a dictionary also if you want. We'll add what value? Sorry, we cannot add it like that. 12 comma 12 comma. What value should I give here? I'll give it a list. Okay. What do you guys think? Will this be a tuple or will it show an error? It won't show an error. You can absolutely add whatever type of element you want to insert in it. Now, say I want to access a particular element out of these elements. Okay, these elements that I have created for my tuple. How will I access them? Simple. You will use indexing. In tuples, it also follows the order of indexing from zero onwards. So, say I want to access the um, string element out of this tuple. So I'll access one. I get my list. I get my string out of there. Okay. Now, what is the length of this tuple? Think about it. By the way, we cannot use this len function in dictionaries at all. If you try and use a len function in dictionaries, it will show an error. See, oh, sorry, it does show. Sorry, it just gives you the number of keys. In dictionary, it just shows you the number of keys. Yeah, sorry, my bad about that. Okay. This len shows the length of the tuples. Now, inside of this tuple, I have created elements which have their own dimensions, right? Okay, but their dimensions are not taken into consideration when counting the length of its own individual element. Okay, what I'm trying to say is that it will treat this whole nested tuple as a single element, the string as a single element, this whole dictionary as a single element, and hence its length comes out as 5, a simple 5. Although I can see that I've created a lot of many elements. Okay, what if I want to access the 67 here? What will I do? What is the index location for this tuple here? 0, 1, 2. Okay, 2. Then in this tuple, what is the position of this tuple? It's minus 1. So I'll access that. And inside of that tuple, what is the position of 67? It's minus 1 again. So do you guys think I'll get 67? Of course I'll get 67. See, that's how you can access the elements. Alright then. Then next we have the basic tuple methods, that is index and count. So what does these method do? As count suggests, it will just count elements that are similar to it, like the occurrence of a particular element. Now I'll create a tuple called as T4, T3, and I'll give it the values as, okay, all right. This is my tuple. Now, I want to know the first occurrence, like where does 5 first occurs or where does 6 first occurs. I don't want to count. Okay, there are like so many elements. I don't want to count. Like what is the index location of 6 or something else. So what will I do? I'll do t3 dot index 6. It returns to me the index value of its first occurrence. If I do t3 dot index, say, say 5 only, will give me 4 because it first occurred on the index 4, 0, 1, 2, 3, 4. It does not take into consideration the rest of the occurrences. It considers the first occurrence of that particular element. Then we have the count method. What does count does? It counts the number of frequencies for which an element has occurred in that tuple. Say I want to count how many times I have injected 1 inside of this tuple. Okay, 5 times. Great. Then what about three? 4 times. See, so this is all about tuples. Now, let's move on to sets and booleans. Okay. Before that, you might consider why do we actually use tuples, as it has very few basic built-in methods, and also we cannot edit it, right? I cannot do this at all. See, T3. One second. T3 is equals to T3. 3 is equals to 1. It does not support item assignment. So what do I use it for? Basically, tuples tells me that it won't be changed. I have a condition in which I need to compare the original list with other objects or other procedure later in the code. Then what do I use? Then what do I do? If I use a list, it is immutable. It is mutable, right? It can be changed, but not tuples. Tuples will retain the initial sequence in which I was given, and it won't change any of the elements. Okay, you can say that I can do that in string also. Yeah, you can do that in string also, but then there's the issue of occurrence of spaces in between it. You would need to use the dot join method, so it becomes a bit more complex. With tuples, if you want to keep an element completely unchanged till the end for some purpose in a code, you use tuples for that. Okay, good. Okay, so now let's talk about sets. Sets is an unordered sequence which cannot retain a element twice in it. Okay, we can create a set using the set function like this. Now my element S is a step. Okay, now how do I add elements in it? I'll add elements like S dot and 1. Now S becomes 1. Okay, now what if I want to add another element? I'll add 2. Now S becomes 1 comma 2. Now I feel like I want to add 1 again. Now let's check. Shouldn't there be two occurrences of S, two occurrences of 1 in my set S, right? But no, we just get one occurrence because set only retains a single time. Like it has to be unique. The elements inside of it should be unique. Okay. Although you can see that the output is shown in curly brackets, it does not mean it is a dictionary. Okay, in dictionary you will see the keys against the values too. This is set. Okay, now what do we use it for? Okay, see, we had created this tuple T3, right? It had multiple occurrences of different elements, right? What if I do this? S1 is equals to, what is the name of that tuple? T3. Okay, set T3. It gives me the elements, the unique elements from my tuple T3. Okay, and you can do this method with any of the other data types. You can do it with list also, and you can do it with tuples. Okay, this is the basis of set, and the built-in functions that you can see in set are these functions are not that used in the programs generally. Basically, you add in the things, you copy in the things, and sometimes say you why do you actually use set? See, set is used when I want to know particular elements like unique elements. That's what it is, right? Unique element collection. Although it's unordered, all these elements would be present there, all the unique elements. So if in a list I am given occurrences of 1,000 elements, 1,000 numbers, and there can be repetition of any of the 1,000 natural numbers in this list. So how do I know that what's the unique numbers that are occurring in this list? I can typecast it as a set and obtain the values which are unique in that list. Okay. Good. That's about it for set. And then let's move on to Boolean. Okay. Boolean is basically something that we have studied even in our physics in 11th 12th standard, like true false kind of things. Okay. uh, True and false basically signify the integers 1 and 0. They can also be used as a placeholder and all. Okay. And generally they're used as outputs or to iterate through a while loop in which we have not specified any condition. We just know that okay, this is some kind of dubious situation which may occur. In that, I want this while loop to become false. This false, see, this false becomes bold and dark green, right? This shows that this is a keyword, and this keyword is a Boolean keyword. But this is not a Boolean keyword, the small lettered false. Okay, the capital lettered false would be a Boolean keyword. Similar for true. Okay. Generally, these Boolean values are showcased when we use our comparison operators. Okay. Now, when we're talking about comparison, okay, what kind of comparisons we generally make? If something is less, if something is more, if something is not what we want it to be like, if something is exactly what we like. So basically, with regards to that, there arises some very unique situations that we use. These comparison operators, which we will be using, their output generally tends to be our Boolean values. See, is 5 equal to 4? My output would come as a Boolean value false. This is the comparison operator of equality. Like, is the left hand side and the right hand side value equal or not? This is what this comparison operator does. Okay. Now, what if I do this? My output comes out as true because obviously 5 is not equal to 4. Now, what if I want to know if the left hand side value is greater than the right hand side value? Okay, it comes out as true. What if it's greater than or equal to the right hand side value? It comes out as false, and vice versa it goes. Like right now we're doing greater to the left hand side, then we can go to the less than to the right side. So this is the comparison operators, and these are the basic data types that I have covered. Okay. Apart from this, I want to talk about files with you. Why I want to talk about files is because um, generally when you're doing Python, you tend to get into the ML AI side. It fascinates you. You go into that side. What does file have to do with this? You see, in files, in ML or AI, you create models. Okay, you create models on the basis of data. And how do you access that data? That data is present in files, right? And now the files could be of any form. They can be CSV files, they can be normal text files, etc., etc. Okay. So we use these file methods to work on extracting data or information or writing into files to take a note or make something that would have occurred, okay, and to notice so that we can remember that. That's what these files part of notebook does. Okay.